So the reason that you know we're all here is because we're PHP engineers. And one of the things about PHP that is really interesting to me is the fact that it's very young. It's changed a lot. PHP had absolutely no, it wasn't intended to be what it's supposed to be now. It was never really, everybody here knows how PHP started, right? Yes? Anybody not know? Okay, good. I'm going to skip one of the slides then. Okay, so who am I and why am I talking? I'm Declan. I'm a principal engineer here. Been doing this for a while. I used to work at News Limited some years ago. Is anyone at News Limited right now? Yeah? News Life Media or News Digital Media?
I work in the media section.
Oh, cool. Right. You probably know a few people I do. Yeah, spent a lot of time doing PHP jobs. And one of the things that I've noticed a lot about PHP jobs is because of what I said before, which is that PHP has not been around forever, is that quite often when you go into an organization to do PHP code, pretty much every single company that I've ever worked at here that does PHP code has a lot of classic code. And I want to say classic code because a big part of this is that we all as engineers have a particular desire to try out new things and to learn new things. And sometimes what that can do is it can lead us to have a really skewed and very negative perspective on things that have happened in the past. And a big part of what I'd like to do is to kind of just give a few ideas about like why I actually really like old code and why I think it's something that we should respect instead of something that we should be upset about having to work on. So we'll start with a brief history of PHP. This is the slide I was probably going to skip. But so PHP was created in '95, created by one person, as we all know. It was called Personal Homepage. It was never intended to be used for 82% of the web. Granted, that number's a little bit skewed because people use PHP for landing pages a lot, but the point is PHP is in use a lot. PHP is everywhere. People are using PHP for all kinds of things. It's powering a huge amount of the internet. It also changed really fast over a really short period of time. Like if you started doing PHP 4 or even PHP 3, and then somebody put you in front of PHP 5 or PHP 7, you would go, what am I looking at? It's really different. Like it's changed a lot. And the techniques that people used to actually do very similar things, the kinds of things that we all do now that we consider to be important, dependency injection being one of the biggest examples, these things changed a lot. Like in the space of 10 years, things are completely different. So the language is really popular for good reasons. Now, those reasons are, it's really fast. That's cool. It's also a really smart way of creating a runtime for the internet because it's a stateless runtime. Comes up with, from the beginning, it reassembles everything right from scratch and then does what it needs to do. So that actually, in a lot of respects, makes it perfect for the kinds of things that you want to do on the internet because it means that you can recover a lot more easily from problems and it's just a smoother way of doing things. But it has changed a lot in that 25 years. So just remember that, like it's changed a lot. So the first thing I want to talk about is what you can actually learn if you go to the effort of really, really, really wanting to understand code that you're looking at. And I'm going to say classic code because it has very, very different connotations to other words for it. But so the first thing is, who here is currently working at a company that does PHP? Okay, most people. Would it be safe to say that without the code that your company has maintained, it probably wouldn't be around anymore? Yeah? So the important lesson here that we're going to have a look at is the code is the business. Like, it doesn't matter whether the code is perfect. It doesn't matter whether the code is pretty. It is the business, and it's the reason that we get paid. So, for starters, This is a bit of code that I kind of encountered actually at News Limited. You look at that and you go, it's kind of a mess, right? But the thing about this is what this code is doing is actually really, really transparent. Like there's no way to hide what this code does because it just shows you right up what it's doing. So what can you tell by looking at this? Well, first thing that you can tell is that, let's have a look. So looks like we've got something important. We need to have a session to get started. Okay, we just learned something. Here, we just learned that if there's no user, you can't access the page. So we now know this is a secure page. And we also know that there's this weird thing going on here with like session variables and things being passed on. Now, in the case of this code, this is actually kind of a pseudocode example of something that's used to allow advertisers to target advertising across multiple pages on a site. Simple. It's not a big deal. But it's also responsible for millions and millions of dollars of revenue that that company pulls in every year. So that's a pretty important thing that, you know, yes, you can encapsulate a lot of these things, but you can actually learn something just by looking at this. Now, there are better ways to structure this code, but this code will teach you what it does very easily, which is really important. We go on to the next part. So as I said before, the code you're maintaining got the business where it does today, so it is doing something right. So a lot of important learnings from years in the market do live in that code as well. That's the thing. Like, it's not, the code is the business in the same way that every other part of the business is feeding ideas into the code. The code is also feeding ideas back into the business. And the things that are in the code will tell you what is important to the business and what has been important to the business. A good example today, we had a meeting where Deputy has been around for a while. Let's put it that way. So the code base of Deputy is about, I think the current code base's history is about 12 years old at this point. And there are some parts of it that haven't really been looked at very much for a long time because they just work. And they make a lot of money for the company. So, you know, all of those learnings from that are in there. And today we actually had a really good discussion about, you know, some changes that we were making. And an engineer who's been around for a long time was like, oh yeah, the reason that the code does this and the reason that it's structured like this is because at one point we had an idea that we were going to go down this path as a business. And then we decided that was too much of a hassle. So we decided to go down a different path as a business. And now we've come full circle and we're coming back around to this part of the business. The thing is though, all of that is in the code. Like, you know, it's great to have somebody there to teach you that as well. But if that person's not around anymore, as often happens in software companies, you've got the code and nothing else because the code is the business. So next one is a simpler one, which is that I'm a big fan of testing. Does anybody else like testing? Yeah. Okay, good. All right, good, good, good. The thing about testing that's interesting is that quite often it can be hard to write good tests up front. And the reason for that is because good tests rely on good acceptance criteria. And I don't know about everybody else, but I have never really been fully satisfied with any acceptance criteria I've ever been given. Like, it's always missing something. You always have to fill in blanks. Acceptance criteria may not be completely and utterly like upfront, you know, covering off everything that it needs to. But the thing is, if code has been in production for a while, it does, because its acceptance criteria have actually accumulated over time. It's not acceptance criteria where someone sat down and gone, in order for this component to do what it needs to do, I need X, Y, Z to be satisfied. It's more like, over time, you realized that these components did these things and they needed to do other things, and you added more functionality to them, you built them up. And oftentimes what you end up with is something like this, as an example. So this has problems. I think everybody would agree. This is not a piece of code that you really want to find yourself maintaining. So one of the good things about this code is, though, if you want to change this code and you don't want to break everything, then you need to test it. Now, nobody is going to come up to you and give you the acceptance criteria that this code tells you. It's very rare that someone's going to come along and say, okay, the code, my acceptance criteria say that the password needs to be between 12 and 32 characters. We know it needs to have a number. We know it needs to have one of these special characters. Your security team might give you those very specific acceptance criteria, but a lot of the time, these things will build up over time. And you will find new requirements. You will find new things that need to go. Now, the good thing about this is, though, this code shows you what it does, which means that writing a test for it is really easy. So you can now write a test for this code because it's told you all that it does. You don't need to go through and look at acceptance criteria. You don't need to go and read documentation. You can look at the code and go, yes, this is what this code does. And this is how I can test that this code does exactly what I expect it to do, and then I can change it. So this is something that you can't easily get unless you have code that has been in production for a while and that has been built for a while. It's hard. You know, you need to actually get these things over time. They don't just spring up. So writing good tests up front is the best thing. Like, you know, I'm a big fan of TDD, less so BDD, but, you know, I like to write tests up front. But the reality is that your tests up front are just going to be like, does my code actually work? Does it have the stuff that I need to do? Okay, cool, that's enough. And then you'll add to them over time and you'll build them up. But the reality is that if you have code that is already complete, you can actually see what it does and write tests for it. Like, it sounds like a simple thing, but it's actually, you know, something that you don't get if you're just starting from scratch every time. So the third part about this is that you really need to free your mind a bit when you look at old code. And I think one of the big problems that we have is that as engineers, we look around and we look at what all the new and exciting things are, and we look at all of the way that things are, and we go, oh, hang about, like, we see stuff that doesn't fit that mold and we go, oh, wait, this is unacceptable. But, you know, there's a reason there's an Isaac Asimov quote in there, but, and that is that, you know, your assumptions are the windows on the world, and if you scrub them off once in a while, you need to scrub them off once in a while or the light won't come. And that's how it is. Like, you know, here's a good example of something that you will see in most PHP applications these days. This is a controller. This controller takes requests, has a response object that it returns back. You set data on the response and you return it. That's, you know, that's very clean. It's very nice. But I would say that figuring out what this code actually does is much more difficult than if it did everything in a really, really old way, such as this. This is not maintainable. This is not something that you would recommend. But this code actually tells you what is happening. This code doesn't hide anything from you. There's no kind of like framework in place that will automatically escape all of your inputs and sanitize them for you. You can't do any of that. You actually have to look at this code and see what it's doing. And by the end of that, you will know what the end result should be. It's not a very exciting piece of code, but you know, you can see what it does. You can learn new ways of getting, of doing things. So this is actually an interesting one. I gave this talk a couple of months ago to the deputy engineers, and the topic of filter input came up. And the reason the topic came up is because a lot of engineers have never used it. And the reason they've never used it is because they use frameworks that do that for them. They don't need to know how to like sanitize input. Why would you need to know how to sanitize input? I have a framework that does that, you know, which is fine if you're a Rails developer. But no, okay, all right. But the point is that if you're like trying to understand what the code does, and you're trying to understand the low-level things that happen in the process of the code running, there's a lot of knowledge there, and there is a lot of things that you can actually take away from that you can't get when you're using heavily abstract frameworks. It just doesn't work. So the takeaway here is frameworks are great. Don't get me wrong. I'm a big fan of Symfony myself. Slim PHP, I've done a few projects in recently, which I really liked because I was really sad that they got rid of Silex. So, you know, those are all really good, but they, by their nature, are designed to abstract things for me. You're not supposed to know the low-level implementation of cookies, headers, requests, database connections, all of those things, which we actually now just assume are just going to be provided for us. You don't need to know any of those things. If you can learn about the common solutions to low-level problems, you can learn a lot. Like there is a lot of power in those low-level solutions to things. Like it will get you somewhere that you couldn't get otherwise if you learn more about what the underlying implementations and technology of these things are. So this is the fun part. Now, the purpose of saying that maintaining classic code is something that we shouldn't be afraid of and that we should be encouraging and we should be embracing, the purpose of that isn't to say that we shouldn't get rid of classic code. Because, yeah, there are some ways, in some ways, classic code can become a bit of a liability. If it's not maintained, there are security problems, there's all kinds of things that you've got to do. And this is why the Strangler pattern was, I don't want to say created, but I guess was, you know, established or described some years ago. And the Strangler pattern, do people know the Strangler pattern? Yep, okay. There's a link in here and we'll share the slides afterwards as well, but the original, I think it was the original, the Martin Fowler article about it from 2004, I believe, describes it very well. But so well, in fact, that I've actually included this whole paragraph from it. But so first off, now, this was very funny. We were talking about this earlier, but originally this was called the Strangler pattern. And Martin Fowler actually, for the first time in 15 years, edited the article this year because he realized that he wasn't really very happy with the violent connotations of the Strangler pattern. Because when you tell people that you're doing it with the Strangler pattern, people tend to think that you're a psychopath. And that's understandable. If somebody came to me and said, learn about the Strangler pattern, I would go, please go away as quickly as possible. So just to be clear, the Strangler pattern refers to strangler figs because Martin Fowler was on holidays in Queensland and he and his partner were on a bushwalk and he saw these strangler fig trees and he went, those are beautiful. So you know the trees, the ones we've got the big vines hanging down, this picture over here, there's heaps of them all around Sydney. And he had somebody explain to him what the strangler fig does. And what the strangler fig does is it seeds itself. So underneath all of this, there's a tree, but it's not a strangler fig tree. A strangler fig has seeded itself up in the tall branches of that tree. And over time, it slowly chokes the tree under it to death. So yes, it is very violent actually, but it's tree on tree violence. So it's a little bit nicer. So yes, think gardening, not murder. Okay. It's slow, it's much slower. Yes, it's apart from other things. But the whole point of the strangler fig pattern is that what you want to do is you want to kind of at the edge of the code that you're creating, you create sensible abstractions between things. You create divergent code paths and you create ways to quickly switch between those different code paths. So as an example, actually the last company that I was at was a company called Expert 360. And, well, what's that? What do you? Nothing. Oh, you've talked to Alan, haven't you?
Never heard about it.
No, never heard about it. So Expert 360, when I started there, big surprise, they had a monolithic classic code PHP app that had developed over several years and was also responsible for all of their revenue. So what we started doing was we started using the Strangler fig pattern to start to slice away parts of that and move them into other languages, other services, and just try different things. So in our case, what we did was we put Nginx in front of everything, and then we just routed to different services. It's a really simple way of doing a Strangler pattern, but it's actually a very effective way of slicing out parts of your application, rewriting them, making them work better without any interruption of continuity for your users. Your users have absolutely no idea what's going on. It just happens. They just go to the URL and there's this thing and it's, oh, it looks a bit different, but okay, you know. So this gives you an opportunity to actually go, all right, I've identified these classic chunks of code. I've looked at them and I've learned what they do. I understand what they're trying to do now. Now I can start to strangle them. Yeah. So the important thing is the Strangler fig pattern does allow you to slice these things away. But the whole point is eventually you're going to modernize your whole application by slicing off bits and pieces of it as you go without any interruption of continuity for your users. And you can only do that if you actually learn and respect the code that you are replacing. You can't just go into it and go, oh, yeah, okay, well, we're going to build a new, I don't know, like we're going to add forums. It's like, why? Nobody uses forums, but we're going to add them anyway. We're going to add forums. And it's like, okay, well, in order to add forums, we're going to need to change the user management and the user onboarding system somewhat. We're going to need to change the way that users actually get into the system. Like, oh, cool, I'll just rewrite it. Like, well, hang about. Like, how are you going to do that? How are you going to do that without breaking everything else if you don't actually understand it anyway? So in order to actually effectively remove any risk or liability that comes with actually overhauling a big system, you need to have a strategy that respects the original system, but also understands the original system and also smartly encapsulates things to protect you from the original system. So that's how we do things. That's pretty much all I have to say, honestly. Just got a few closing thoughts about this, which is that, like, as a PHP developer, you're probably going to find yourself in front of old code. Who here has looked at code that was older than, say, 5 years in the past week? Wow. How did it make you feel? No? Didn't make you feel much? No. Okay.
The desire to strangle was right.
Okay, yep. Fair enough, yeah. And that's fine, yeah.
Have you seen the comment?
All of these are valid reactions, honestly. Like, it's not always fun to do these things, but remember, it is actually what runs your business as well, you know? Like, you wouldn't be here, I wouldn't be here, none of us would be here if it weren't for the people who came before us, you know? And like, I mean, yeah, it would be great if we had dependency injection containers in 2004, but we kind of didn't, you know? Had a lot of static get instance calls, love those. But yeah, like, I mean, things change over time. And I think if you actually take the time to really understand that, you know, why people make decisions that they make, and to also always assume the best intentions of every developer who came before you, that's sort of like the inverse of where you should always write code as though the person who's going to maintain it is a serial killer who has your address. So you want to be the opposite to that. You want to be the opposite of the serial killer. You want to look at that old code and go, oh, okay, well, you know, I can learn from this. Things about the business, maybe not about PHP coding techniques that are best practices for the year 2019. Probably very unlikely that you will learn those, but it's not a bad thing. And that's it.